In this video, we'll look at some complicated factoring where we have some pretty big numbers. So let's look at our first problem, 15x to the 6th minus 2x to the 5th minus 24x to the 4th. First step in any factoring problem is to look for a common factor. In this one, numerically, I don't have any common factors between 15, 2, and 24, but I do have an x in each term. So there'll be a common factor of x raised to the lowest power I see, which is x to the 4th. Common factor then, factoring out x to the 4th, leaves us with 15x squared minus 2x minus 24. The rest of the problem will be focusing on factoring the trinomial in the parentheses, 15x squared minus 2x minus 24. But x to the 4th, the GCF has to be part of my final answer. So I'm going to come down and write my answer, at least sort of what I call a draft of my answer, with the common factor of x to the 4th. Now I don't have to worry about that because I've already brought it down, and now I can just concentrate on the rest of the problem. So factoring a trinomial, we could try trial and error, or we could try the AC method. And if I decide on the AC method, that means I'm going to have to multiply a times c, which is 15 times negative 24. That's negative 360. That's really huge. So I think I'm going to stick with trial and error instead and see if I can get it that way. So let me show you some tips for getting the answer by trial and error, hopefully as quickly as possible. Remember, in trial and error, I'm taking 15x squared and splitting it as something times something. So let's see what our options would be for 15x squared. Could be 15x times x, or could be 5x times 3x. First tip is, as your first guess, try the 5x and 3x first. It doesn't always work, but it's better to try the numbers that are closer together as your first guess. For negative 24, my choices would be, and I'm just going to worry about the 24, not the negative part of it. So I'm going to multiply 24 times 1, that's one possibility. 12 times 2 is another choice. 8 times 3, or could be 6 times 4. So again, next tip would be to try the numbers closest together first. So I'm going to try the 6 and the 4. Second tip is that there's some possibilities you can eliminate right away, because with the 6 and the 4 I have the choice to put 6 and then 4 or 4 and then 6. If I chose 4 and then 6, I know right away that is not going to work. The way I know that is we've already checked and said there is no numerical common factor in this polynomial. That means there will not be any factor with a common factor either. So if I put the 6 with the 3x, that would give me a GCF of 3. I know that won't work, so I know without even checking by multiplying that I can't have any possibility that puts the 3 and the 6 together. So we can just move on and try the next possible combination, sticking with the 5x and 3x, but let's try the 4 and the 6 in the other direction. First the 6 and then the 4. Now we need a one sign of each in order to equal a negative 24. So our last term is negative, so I know I need one positive and one negative. I can check it by multiplying the outer terms. That gives me 20x. And then the inner terms, minus 18x. That equals a positive 2x. Gosh, I had hoped to get a negative 2x, but I'm close. I just have the wrong sign. And so if that's all I need to change, all I need to do is switch the signs and make it first a positive and then a negative, and I've got it. So it'll be 5x plus 6 times 3x minus 4 in my final answer. So we got it pretty quickly that time. We don't always get it that quickly. If that hadn't worked, my next choice would have been to move up to the 8 and 3, then the 12 and 2, and if none of those worked, then I would try the 15x and the x. Well, let's try our second one here, negative 12x to the 4th plus 98x cubed plus 90x squared. First step, always look for a common factor. I again have a common factor of x in all of them, but I also have a numerical GCF here. I have a negative 12, 98, and 90. Let's see what would be my greatest common factor. They're all even, so I know I'm at least going to have a 2, but we might do better than that. But if we try some numbers, we're going to find that there isn't anything better than 2. So we're going to have a common factor of 2x squared. So I could factor that out. But I'm going to suggest that we not only factor out 2x squared, we also factor out a negative. We have the choice always of factoring out either a positive or a negative. And if it begins with a negative, I would suggest you factor out a negative. So when I factor out negative 2x squared, that will leave me with 6x squared. And now the middle term is positive. So if I'm factoring out a negative, I have to have a negative. So negative times negative gives me that positive back. 2 goes into 98 49 times, so we get minus 49x. And then again, 90 is positive, but factoring out a negative means I'll have a negative. 2 divides into 90 45 times. And so negative 2x squared, the GCF, needs to carry down into the final answer. So I'm going to go ahead and write my final answer with my binomials so I know what I'm shooting for, and now I don't need to worry about the negative 2x squared anymore. Again, if I tried the AC method, 6 times negative 45 would be a really big number to deal with. So let's just try some trial and error and see what options we have by going off to the side and writing out what would be my choices for 6x squared. My options would be 6x times x or 3x times 2x. I'm again going to use the closest possibilities first. So let's take 3x and 2x as our first guess. And we'll try 9 and 5 as our second guess. But again, there's no point in trying the 9 with the 3 because there's a GCF there. I won't have a GCF in here because I've already factored out any GCF, so I don't even need to try that one. But let's try the 5 and the 9. Since the last term, negative 45, is a negative, I need one of each sign. So let's try a positive 3, or I'm sorry, a negative 5 and a positive 9. So the outer terms then, if I check, that I would get 27x minus 10x. Doesn't work, that's not negative 49x. So I'm going to move on to my next choice. Let's try 3x, 2x. My next choices are 15 and 3. Now I can't try the 15 here because I'd have a common factor, so no good. I can't try the 3 here either though. So the 15 and 3 is not going to work. So let's go to now 45 and 1. Again, I can't have the 45 here, it's not going to work. So the only thing I need to try is 1 and 45. So if I do one positive and one negative and test the outer plus the inner is 3 times 45. That's a big number, minus 2x. No way I'm getting negative 49x out of that. Well, that killed all our 3x, 2x possibilities. So in this case, it turns out that one didn't work. It's still the best thing to start with in general, but sometimes it doesn't work. So now what? Now I go to 6x and x. So now let's try our possibilities with 6x and x. Again, now on the 45 list, going to the closest possibilities first. So 9 and 5. No need to try the 9. That would give me a common factor with the 6. So the only way I'll need to try it is a 5 and then the 9 over here. So let's try a plus and then a minus. So if I try that, if I multiply my outer plus my outer would be negative 54x, inner positive 5x. Ooh, that's negative 49x. Ta-da! That's what we wanted. So now we've got it. It's 6x plus 5 times x minus 9. So on these trinomials with the big old numbers, I do suggest you use trial and error rather than AC method and do the systematic method I just showed you. Write down all the possibilities, start with the numbers closest together as your initial guesses and move through systematically. If your initial guesses don't work, eliminate anything that gives you a common factor within within one of the binomials. You don't even need to try multiplying that one. It's not going to work.